Deep in the southern sky, beyond the reach of city lights, and within the stillness of the constellation Hydra, a strange whisper pulses through space. It's not a whisper in the way we know sound, but a quiet rhythm of radio waves that seem to murmur from across the cosmos. They don't come from a star, a planet, or a black hole. These signals flicker in the quiet band of the radio spectrum with a strength and regularity that feels deliberate. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're watching from and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. We begin with a signal that first appeared in 2020, pulsing like a heartbeat from the center of our galaxy. Astronomers at the Australian Square Kilometre Array Pathfinder, ASCAP, noticed something odd, a narrowband radio transmission, blinking on and off every 18 minutes with uncanny precision. Not once, not twice, but again and again for months. Then silence. It was unlike any natural emission known to science. Stars don't behave this way. Pulsars, the dense, spinning corpses of exploded stars, can blink rapidly, but not this slow. Black holes emit X-rays and gamma radiation, not tidy, repetitive radio blips. And flare stars, which can brighten unexpectedly, do so irregularly, not in these clockwork intervals. The object in question, named ASCAP J173608.2321635, sits 4,000 light-years from Earth and follows no known rules of astrophysics. To the team watching it unfold, it was both thrilling and deeply unsettling. The signal would blink on, lasting around 30 to 60 seconds, then vanish. For precisely 1,080 seconds, there was silence. Then it would flash again, not in a continuous stream, but like the ticking of a cosmic metronome. Then, weeks later, it disappeared entirely. Telescopes were aimed at it again and again. Nothing. Total radio silence. Then, months later, it returned. The behavior was so bizarre that scientists seriously began to consider if it was artificial. A deep space beacon, a rotating transmitter. It was only natural to wonder, because nothing in the known universe pulses that slowly and with such regularity, while being invisible in every other wavelength. No light, no X-rays, no heat, no visible motion. The strangest part? The object wasn't near any obvious star system. It hovered near the dense, dust-obscured center of the Milky Way, where few telescopes dare to look. And even more oddly, every time they tried to pinpoint the signal's location more precisely, it seemed to shift. Not by much, but just enough to make things uncomfortable. To some, this might sound like the setup to a science fiction tale, but the data is very real, published and peer-reviewed. The team behind the discovery tried to classify the source. Is it a magnetar, a white dwarf, a black hole with a companion? None of the models fit. Its brightness was extreme when it appeared, but gone without a trace in infrared, ultraviolet, or optical light. This led to a radical suggestion. Could it be something entirely new? Astronomy has a rich history of phenomena that began as mysteries. Pulsars, for example, were once nicknamed LGM, for little green men, because of their perfect timing. Quasars, now known as supermassive black holes at the centers of galaxies, once baffled scientists because they seemed far too bright to make sense. But ASCAP J173608.2321635 stands apart. Its pulse is slow, its nature unidentifiable, and its silence between bursts oddly peaceful. Imagine it, a signal crossing the dark vastness of space, traveling for 4,000 years, only to be caught by human ears in the quiet deserts of Australia, then disappearing again, as if hiding behind the curtain of the universe. What might cause such behavior? Some theories suggest ultra-long period magnetars, highly magnetic neutron stars that rotate slowly. These objects are hypothetical, with only one confirmed candidate so far. But even those don't explain the sudden vanishing. Magnetars usually leave traces, X-ray flares, or gamma-ray aftershocks. This one left nothing but a memory of rhythm. Could the answer lie in our own limitations? Perhaps we don't yet know what to look for. The universe is under no obligation to reveal its secrets in ways we understand. Still, as our instruments grow more sensitive and our algorithms more refined, we might catch this signal again, or others like it. Already, machines are listening to the skies day and night, searching for patterns too faint or too brief for human eyes to catch. Somewhere out there, other cosmic whispers might be waiting. But for now, we're left with a mystery that feels almost poetic, a deep, slow pulse echoing across space like a distant drumbeat. A heartbeat in the cosmos, reminding us that not everything is meant to be explained right away. We often imagine space as silent, static, and cold. But this signal proves otherwise. It suggests that something, somewhere, is moving with purpose, even if we can't yet define what that purpose is. The universe isn't quiet. It's alive with patterns we've only just begun to recognize. And as we rest beneath the stars, perhaps we're not just watching the cosmos. Maybe, just maybe, it's watching back. The light from Tabby's star first reached Earth long before our ancestors learned to write. For millennia, it was just another point of light in the Cygnus constellation, a nondescript F-type main-sequence star, a little larger than our sun and just as ordinary. Until it started blinking, not a slow fade, not a periodic eclipse like stars often do when an orbiting planet crosses their face. No, Tabby's star, also known as KIC 8462852, began dimming in ways that no one had ever seen before. Irregular, unpredictable, dramatic drops in brightness, some up to 22%, far beyond what even a gas giant planet could produce. The discovery came from Kepler, a now retired space telescope whose job was to stare at hundreds of thousands of stars and wait patiently for them to wink. Those tiny dips in brightness were the signatures of orbiting exoplanets. But in 2015, when astronomer Tabitha Boyajian and her team analyzed the light curve from this particular star, their jaws dropped. Kepler had observed the star dimming not once, but dozens of times, and not by a fraction of a percent, like with typical exoplanet transits. These were massive dips, erratic and inconsistent. No pattern, no repetition. Sometimes the star dimmed for a day, sometimes for weeks. Sometimes it returned to full brightness in hours. Other times, it faded and stayed that way. There was no known physical explanation. It wasn't just strange, it was unexplainable. Scientists rushed to find natural causes. Could it be comets? Perhaps a giant swarm of icy debris from a shattered planetary system had drifted in front of the star. Maybe the star was surrounded by a warped disk of dust. Or maybe, just maybe, it wasn't natural at all. This is when the media, and even a few cautious scientists, whispered the phrase that always sparks wild speculation. Alien megastructure. Imagine, if you will, a vast artificial object, a ring, a series of platforms, or even a Dyson swarm, designed to orbit a star and harvest its energy. If such a thing existed, it might partially block a star's light, just as Kepler recorded. The idea was first proposed in the 1960s by physicist Freeman Dyson, and for the first time, we had a candidate. Of course, most scientists remain skeptical. Extraordinary claims require extraordinary evidence, and the alien hypothesis is often a last resort, but the mystery remained. As data piled up, it became clear. Comets couldn't explain it. There wasn't enough infrared light from the supposed dust, and no known planetary system could produce such chaotic dimming. Even stars surrounded by debris disks don't behave like this. Then, something even stranger happened. Ground-based telescopes started monitoring Tabby's star after Kepler's mission ended, and they noticed a slow, long-term dimming trend. Not short dips this time, but a gradual fading across years. No one could say why. Stars don't just get dimmer for no reason. Something was clearly happening, but we had no way of knowing what. One hypothesis suggested interstellar dust, Maybe we were just looking through a patch of cloudy space. But that theory quickly lost traction. The dips in brightness were not evenly spread across different wavelengths of light, which interstellar dust would produce. They were frequency specific, meaning some colors of light were blocked more than others, just like what you'd expect from structured, uneven objects. The plot thickened. Some proposed that the star itself was behaving abnormally. Perhaps it was undergoing a never-before-seen stage of stellar evolution, flickering due to internal processes. But that raised more questions than it answered. Why this one star? Why now? Why in such irregular patterns? For a while, the scientific community settled into an uneasy silence. The excitement cooled. The alien theories were shelved. But the star kept dimming, always in new, baffling ways. It behaved like a celestial puzzle with half the pieces missing. And just when we thought we might have grasped something, it would change again. Fast forward to today, and Tabby's star remains one of the greatest astronomical mysteries of the 21st century. No model fully explains it. No natural process fits all the data. And no artificial explanation has been confirmed. It simply is what it is. A cosmic question mark blinking at us across 1,470 light-years of emptiness. But the most unsettling part? There may be more stars like it. Astronomers have begun scouring the Kepler and TESS databases, looking for similar anomalies. A few candidates have appeared, stars with dimming patterns that defy explanation. They don't all behave exactly like Tabby's star, but the signs are there. This could be the tip of something much larger. What if Tabby's star isn't an outlier? What if we've stumbled upon a class of objects or civilizations we don't yet understand? It reminds us of how limited our knowledge still is. For all our satellites, telescopes, and artificial intelligence, we're still children staring at the stars, trying to make sense of the flickers in the dark. In the quiet hours of the night, Tabby's star continues to blink. It doesn't care about our theories or our limitations. It pulses its irregular light, as if trying to tell a story in a language we have not yet learned to read. And so we watch and wait, because sometimes the universe whispers, and sometimes it blinks. In the golden age of astronomy, the 1950s and 60s, sky surveys were painstakingly crafted by hand. Giant telescopes captured photographic plates of galaxies across the cosmos, recording their ancient light on delicate film. These snapshots of the universe would become the historical record for generations of astronomers to come. It was from one of these old images that a mystery emerged. A galaxy catalogued as NGC 7237, captured clearly in a 1950s plate, was bright, structured, and unmistakably present. It had arms, it had a core, it had been seen. And then, in later surveys, it was gone. Not dimmer, not hidden by dust. Gone, vanished from the night sky. The plate in question came from the Palomar Observatory Sky Survey, POSS, a meticulous photographic record of the heavens. Back then, every dot, every smudge of light had to be verified, logged, and checked. NGC 7237 appeared in these early records without question. It sat quietly in the Pegasus constellation, about 1.4 billion light-years away, a modest spiral galaxy among millions. Decades later, when astronomers re-imaged the same patch of sky using modern CCD cameras, they expected to see it again, clearer, crisper, brighter, but it was no longer there. The location was empty, save for a faint glow that didn't match any known galactic signature. Initially, it was assumed to be an error, perhaps a mislabeling. Maybe the coordinates were off, but double-checking proved the location was right. The starfield matched. Every nearby object was still in place, except the galaxy. Some suggested it was a transient event, like a supernova, but supernova brighten and fade in weeks or months, not centuries. Others wondered if it had merged with another galaxy. But mergers leave behind dramatic trails of dust, warped arms, and colliding matter. None of those features existed in the updated images. The object hadn't changed. It had vanished. This led to a stunning question. Can galaxies disappear? The thought seemed absurd. Galaxies are vast, billions of stars stretched across hundreds of thousands of light years. They don't just wink out like dying candles. Even if a galaxy's stars were to all go supernova in unison, an impossibility, their light would echo across space for millennia. Something else had to be going on. A few proposed a more exotic explanation: gravitational lensing. Perhaps a massive object had passed between Earth and the galaxy, distorting its light or redirecting it away from our planet. Gravitational lenses can do this. They bend light from distant sources like cosmic magnifying glasses. But again, lensing should warp or duplicate the galaxy's image, not erase it. Then came the speculative ideas. What if this wasn't an observational fluke at all? What if something about the galaxy itself changed? Not physically, but in how we perceive it. There's a theory called the vacuum metastability event. It suggests that the vacuum of space isn't the lowest possible energy state, that there's a deeper, more stable vacuum out there. And if, somewhere in the universe, a patch of this true vacuum formed, it could expand at the speed of light, rewriting the physical laws within it as it goes. If such an event occurred in or near a galaxy, the consequences would be instant and irreversible. The galaxy might cease to emit light in wavelengths we can detect, or its matter might dissolve into something completely unfamiliar. And from our vantage point, it would simply disappear, like the flicker of a candle in a vacuum. But even that is just a theory, a speculative one, without evidence. Another possibility is that we're glimpsing the consequences of a cosmic boundary, an edge between regions of space governed by slightly different physical constants. If space is not uniform, then light traveling across billions of light years might encounter distortions, shifts, or even boundaries we don't yet understand. A galaxy caught on such a boundary might vanish from our visible spectrum, even though it still exists. Then again, it's always possible that we've misinterpreted the old data. Some astronomers argue that the galaxy never existed at all. Perhaps the original image showed a plate defect, or a cosmic ray strike, or a misidentified reflection. Maybe it was a background flare, some transient burst of light from an object far behind the region we now search. But if that were true, why does the 1950s image show a spiral shape? Why does it align so well with known galactic structures? Why does it have a core and arms and proportions that match dozens of other spiral galaxies? And if it's happened once, could it happen again? As astronomers digitize and re-examine more historical sky plates, they found dozens of objects, stars, quasars, and galaxies that have either vanished or dramatically changed in brightness with no clear explanation. One study, the Vanishing and Appearing Sources During a Century of Observations, VASCO project, is dedicated to cataloging these cases. Some of the disappearances can be explained, but others remain stubbornly resistant to logic. It raises a quiet, unsettling possibility. The universe is not as stable as we think. We often imagine space as a static canvas, a backdrop of stars that will always be there, unchanging across lifetimes. But these disappearances challenge that assumption. They whisper of a cosmos that can shift without warning, a universe where galaxies can fade like ghosts. As you lie back tonight, think of that vanished galaxy. Once, it shone brightly. Billions of stars, possibly with planets and perhaps life of their own, spun around its core. Now it's gone, lost not to time, but to mystery. Somewhere, 1.4 billion light years away, something changed. And here, on Earth, we noticed. Look up into the night sky, and you'll see stars everywhere, thousands twinkling like scattered gems. But this is just a slice, a sliver. Because when we gaze deeper, beyond the stars of our galaxy, beyond even the brightest quasars and nebulae, we see a universe filled with billions of galaxies, packed across the cosmos like city lights from orbit. Except, in one place, there's nothing. No light, no galaxies, no stars. just a chilling absence. This region is known as the Bhuta's Void, a vast sphere of darkness stretching nearly 330 million light-years across. It sits in the direction of the Bhuta's constellation, and it's not just empty, it's too empty. Statistically, it shouldn't exist. If you imagine the universe as a bubbly, foamy structure, with galaxies clumping together in filaments and walls, and voids between them acting like the cosmic gaps, then this void is the biggest and strangest of them all. Most voids are like little pockets, 10, maybe 20 million light-years wide, but Bhuta's void, it's so large that if the Milky Way sat at its center, we wouldn't have discovered another galaxy until reaching the very edge of the visible universe in one direction. To give some perspective, light takes 8 minutes to reach us from the Sun. It takes over 4 years from the nearest star. It takes 2.5 million years from the nearest major galaxy, Andromeda. But to cross the Bhuta's void, light would need 330 million years. That's longer than the age of dinosaurs. It's more than a quarter of the time Earth has existed. So how did astronomers even discover this place? In 1981, a team of scientists led by Robert Kirshner was mapping the positions of galaxies in the night sky. They expected the usual clustering, some dense regions, some sparse, but nothing prepared them for the sheer emptiness they found in Bhuta's. It was as if a hole had been cut out of the universe. At first, they assumed it was an error in the data, but follow-up observations confirmed it. This wasn't a gap in the data, it was a gap in space. They found a few galaxies scattered throughout the void. Yes, but far too few. For a region this size, thousands of galaxies should exist. Instead, just a few dozen. Like a city where only 1 or 2 porch lights are left on. It was eerie, but how? In our current understanding of cosmology, large-scale structures like galaxies form from tiny fluctuations in the early universe. These fluctuations act like seeds. Areas with slightly more matter pull in more gas, leading to stars, clusters, and galaxies. The empty areas, the voids, are just regions that didn't have enough mass to form much. But even the emptiest voids still contain something. Bhuta's is different. It's too empty. The statistical chance of such a region forming purely by random fluctuation is incredibly low. Cosmologists estimated that in the observable universe, maybe one void this size should exist, if at all. So what could have caused it? Some theories suggest that something may have pushed the matter out early in the universe's life. Maybe a powerful expansion or event repelled the gas that would have formed galaxies, leaving behind an enormous bubble of darkness. One daring idea is that Bhuta's void is a scar from a cosmic collision, not between stars, not even between galaxies, but between universes. If the multiverse theory is correct, and our universe is just one of many bubbles floating in a larger multiverse, then maybe, just maybe, 2 bubbles bumped into each other early in their formation. That collision could have erased matter in one region, creating a blank space where physics itself was altered, leaving behind a strange, barren hole like Bhuta's. It's just a theory, of course, but Bhuta's void is so abnormal that cosmologists have turned to these exotic explanations simply because nothing else fits quite right. And then there are the more speculative whispers. Some suggest the void could be the result of dark energy behaving differently in this region, accelerating the expansion of space locally, pushing matter apart more aggressively. Others wonder whether something massive and invisible sits within the void. A black hole on a scale we cannot yet imagine. Not the kind that devours stars, but one that warps space so deeply that galaxies avoid it entirely, as if being repelled by its presence. And some, just a few, ask if this might be the mark of something artificial. A civilization so vast and advanced that it has harvested the stars within the region, cloaking their light, or converting them into something unrecognizable. The stuff of science fiction? Perhaps. But when faced with a cosmic mystery, our minds naturally wander toward all possibilities. Yet, despite all the theories and the quiet fears, one feeling lingers strongest when we look into the Bhuta's void: loneliness. It is the most isolated place we have ever discovered, a cosmic desert, a true nothing. If you were to fly into it, you'd drift for millions of years without seeing a single star. You'd look around and find only darkness. No solar systems, no nebulae, no galaxies. Only you, floating in endless black. Some astronomers even call it the Great Nothing, a place where the universe forgot to exist. And maybe, just maybe, it reminds us of how fragile our little corner of the cosmos is, how special our galaxy is, surrounded by company, surrounded by light. We are lucky to live in a crowded, bustling part of the universe, because out there, somewhere in the black sea of space, there is a place where no one lives, where light never came, and silence has ruled for eons. Now, let's drift away from the void, away from the darkness of the Bota's void, and back into the comforting glow of stars and galaxies. Let's visit a place where there shouldn't be comfort at all, and yet strangely, there is. Imagine this, a small, quiet galaxy. Nothing flashy, no spiraling arms, no dazzling core like the Milky Way, just a soft, fluffy puff of stars in the distance. But this little galaxy has done something utterly shocking. It shouldn't be able to exist. And yet, there it is. Welcome to NGC 1052 DF2, often just called DF2, the galaxy that broke the rules of the universe. Discovered in 2018, DF2 baffled astronomers the moment they studied its structure. It wasn't its shape or size that caused a stir. No, it was what the galaxy was missing, something every galaxy is supposed to have: dark matter. Now, dark matter is one of the strangest mysteries in modern science. It's invisible, doesn't emit or absorb light, and doesn't interact with normal matter through electromagnetism. But it does have gravity. In fact, without dark matter, most galaxies would simply fly apart. Their stars spin so fast around the center that they need an unseen mass, extra gravity, to hold them together. It's like watching a merry-go-round spin way too fast. But somehow, no one falls off. That's the effect of dark matter. It's the cosmic glue. Every galaxy ever studied, from the tiniest dwarf galaxies to the largest spiral giants, has shown signs of dark matter. In fact, scientists estimate that 85% of all matter in the universe is dark matter. It's everywhere. But DF2, nothing. No signs of dark matter. Not even a little bit. When astronomers measured how the stars in DF2 moved, they noticed something shocking. The stars were behaving exactly as if only visible matter was present. The regular, ordinary stars were providing just enough gravity to account for the galaxy's structure and movement. This was unprecedented. It was like discovering a functioning car without an engine, or a floating ship without any water below. Some astronomers questioned the measurement. Maybe the distance to DF2 had been miscalculated. Maybe its mass was misunderstood. But after repeated observations, the data stood firm. The galaxy had no dark matter. So, how? No one has a solid answer, but a few ideas have surfaced. One theory suggests DF2 might have formed in a violent tidal interaction. When two large galaxies passed close to each other, the gravitational forces could have stripped away most of the dark matter from a forming dwarf galaxy, leaving behind only normal matter. But that would be an extremely rare and specific event. And even then, it shouldn't have left such a stable system behind. Another idea? Maybe DF2 formed in a region of space where dark matter simply didn't clump together as expected. That would mean there are other galaxies like DF2 out there, quietly orbiting, free from dark matter's grip. In fact, in 2019, astronomers found another galaxy, DF4, that also seemed to lack dark matter, and it looked almost identical to DF2. That raised even more questions. If there are two of these galaxies, maybe they're not accidents. Maybe they're part of a new category of galaxy we just hadn't seen before. The implications are massive. If these galaxies are truly dark matter-free, it means our understanding of dark matter might be incomplete. Or worse, wrong. Maybe dark matter isn't as essential to galaxy formation as we thought. Or maybe it's not a thing at all, but a side effect of some deeper law of physics we haven't discovered yet. And that brings us to a scarier possibility. Maybe our whole theory of gravity breaks down on cosmic scales. You see, most of what we believe about dark matter comes from watching how galaxies spin. When things don't move the way Newton's laws predict, we add dark matter into the mix as an invisible fix. It works, but it's never been directly observed. Not once. So, what if? The reason DF2 and DF4 behave so strangely is because the rules themselves are broken. What if we're applying the wrong kind of gravity? Some fringe scientists argue that instead of inventing dark matter, we should rethink the laws of physics. Maybe space behaves differently on large scales. Maybe gravity gets weaker or stronger at great distances or in strange geometries of space. It's a radical idea, but so is a galaxy with no dark matter. Yet DF2 sits there in space, soft and silent, a mystery wrapped in starlight. It's not flashy, it's not dangerous, it doesn't shoot jets or collide with others. It just exists, quietly, peacefully, and completely against everything we thought we knew. Sometimes the universe doesn't scream its mysteries. Sometimes it just whispers them. And when it does, we have to listen very carefully. Because one tiny galaxy might be telling us, you don't know everything yet. And that, more than anything, is why space is so humbling. Let's turn our attention now to the invisible hum of the universe. Not the stars we see, or the galaxies that glow, but something far more subtle. Something you can't see, but might be able to hear if you had a giant radio ear pointed at the sky. It's 1977. A hot August night at Ohio State University. A massive radio telescope nicknamed the Big Ear is quietly scanning the skies, listening for whispers from the stars. It isn't looking for music or voices. No, it's listening for signals, pure structured radio waves that stand out from the random noise of the cosmos. Most of what the Big Ear hears is, well, boring, static, faint pings from pulsars, bursts from quasars, background fuzz from the Big Bang. But then, something strange happens. At exactly 11:16 p.m. on August 15th, the Big Ear catches a signal. Not a little blip, not background fuzz. This is a loud, clear, precise tone, lasting for 72 seconds. It's strong, it's narrowband, focused on one specific frequency, and it doesn't match anything natural. A few days later, astronomer Jerry R. Amon is reviewing the data printout. Rows of numbers, letters, just the usual, until one line jumps out. There it is, 6 characters, 6EQUJ5. That's not a code or a message, it's how the telescope recorded the intensity of the signal. And U was very intense. So intense that Amon, shocked, grabbed a red pen and circled it on the sheet. And next to it he scribbled a single word. Wow. And just like that, it became known as the Wow signal. Now, here's where it gets strange, really strange. Scientists rushed to investigate. Where did it come from? Could it be a pulsar, a quasar, a military satellite? But none of those made sense. The signal was too narrow, too structured. It came from deep space, and it never repeated. Not before, not since. They pointed other telescopes at the same region, the constellation Sagittarius, but they heard nothing. Silence. As if the universe had whispered once, and never again. Could it have been a transmission from another civilization? A deliberate signal aimed at Earth? Possibly. After all, it was detected near the hydrogen line, a frequency of 14 to 20 MHz that's considered a universal cosmic channel because hydrogen is the most abundant element in the universe. If aliens wanted to communicate, that's a frequency they might use. But the frustrating part, there was no message, just a tone. No words, no code, no hello, just 72 seconds of something, then gone. Over the years, theories poured in. Some serious, some silly. Could it have been a reflection from an Earth-based transmitter bouncing off space debris? A military satellite misfiring? A secret government experiment? Or maybe, just maybe, someone out there saw us and said, "Hi." Still, nothing has ever explained it completely. In 2022, a team of researchers proposed a new possibility. The signal may have come from a sun-like star called 2MASS 1928198226400123, located about 1,800 light-years away. It's not a perfect match, but it is in the right region of space. If that's true, it means the WOW signal could have come from a planetary system not too different from our own. Just imagine, somewhere 1,800 years ago, because light takes that long to reach us, a civilization may have sent out a signal, a brief, purposeful ping. And we, on a little blue planet still inventing radio and electricity, caught it once. What if they're still out there? What if they've sent more signals, but we weren't listening at the right time? Or maybe that was all they ever sent. One message, one tone, like tossing a bottle into a cosmic ocean and watching it drift into the stars. The truth is, we still don't know what the WOW signal was. We may never know. It's like hearing a knock on your front door in the middle of the night, but when you open it, no one's there. Just the memory of the sound, and the question echoing in your mind. Who was it? That's the strange beauty of space. Sometimes it doesn't give you answers. Sometimes it just leaves you with questions that never stop echoing. And maybe that's the point. Maybe the universe is inviting us to keep listening, to stay curious, and to never stop wondering what else might be out there, listening too. Let's imagine something for a moment. Picture a star, but not just any star. This one has already died in the most dramatic way possible, a supernova. It exploded, tore itself apart, and left behind a tiny core. A core so dense, it crushes a sun's worth of material into something just 20 kilometers wide. That's the size of a small city. This leftover star remnant is called a neutron star. But some neutron stars spin. Not slowly, not lazily. They spin fast. Some rotate hundreds of times every second. And as they spin, they shoot out beams of energy, like lighthouses in space. If one of those beams happens to point toward Earth, we see it flash, again and again and again. That's called a pulsar. We've known about them since 1967, when the first one was discovered by Jocelyn Bell Burnell. The signals were so regular, like a ticking clock, that some scientists briefly wondered if they were artificial. They even jokingly labeled the first one LGM-1, Little Green Men. But no aliens were involved. Pulsars are just the universe's most reliable beacons. Tick, 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 flashing perfectly on time, except when they don't. Here's where the mystery begins. Some pulsars do strange things they shouldn't be able to do. Let's look at a few examples. The pulsar that glitched meat, PSR J053769 ping. This pulsar spins 62 times per second. Fast, smooth, predictable. But every once in a while, bam, it glitches. Its rotation speeds up, suddenly and sharply. Why? It's as if something inside this dead star twists, like a spring snapping loose. Scientists think it might be starquakes, literal quakes inside the crust of the neutron star. Imagine a ball of nuclear matter under so much pressure that it cracks. And when it does, the whole star spins faster, like a skater pulling in their arms. But why now? Why only sometimes? Why only certain pulsars? No one knows. The pulsar that disappears. Some pulsars simply turn off. Yes, really. One of the most famous is PSR B11931+24. For 5 to 10 days, it pulses normally. Then, for about 30 days, it goes completely dark. Then it comes back. Like clockwork. It's called an intermittent pulsar, and it's one of the strangest categories of neutron stars ever found. What makes it stop? What restarts it? One idea. Maybe the pulsar's magnetic field is interacting with a cloud of plasma or debris, like something is blocking or choking the signal, and then letting go. Or maybe it's not the pulsar that's changing. Maybe something is moving in front of it, something big, cold and dark. A planet? A failed star? Something else? Again, we don't know. The pulsar that's not where it belongs. Another odd case is XTE J1810-197, a type of pulsar called a magnetar. Magnetars are superpowered neutron stars with insanely strong magnetic fields, trillions of times stronger than Earth's. They're rare, dangerous, and completely unpredictable. This one went from being a quiet, invisible object to suddenly bursting into radio waves, X-rays, and even gamma rays. It lit up like a torch and then faded again. A cosmic tantrum with no clear trigger. Why would a dead star suddenly scream into the void and then go silent again? Are these random, or are we seeing patterns we don't understand yet? The one that shouldn't exist. And then there's PSR J1748-2446A, the fastest spinning pulsar we've ever found. It rotates 716 times per second. Think about that. A city-sized object spinning nearly 43,000 revolutions per minute. It defies logic. Physics says anything spinning that fast should rip itself apart. But this pulsar, it just keeps spinning. What could have pushed it to such speeds? Was it fed by a companion star? Did it steal angular momentum somehow? Or is it something else entirely? These aren't just curious facts. Pulsars are supposed to be the most precise things in the universe. We've used them like atomic clocks, even proposed using them for interstellar navigation. But when they glitch, or vanish, or flash unexpectedly, it's like the universe's most reliable clocks are suddenly lying to us. Why? A deeper mystery? There are those on the fringes of science who whisper that maybe, just maybe, some of these anomalies are not natural. Could an advanced civilization use pulsars as beacons, as navigation points across the galaxy, or even as a way to send signals? It sounds wild, but pulsars are so regular, so stable, that any deviations, however small, attract attention. If you were trying to broadcast something across thousands of light years, you'd want a carrier signal everyone recognizes. You'd want a pulsar. Of course, there's no proof of that, only questions. But the truth is, pulsars still confuse us. For all we've learned, they are reminders that even the most predictable things in space can still surprise us. And out there, spinning in the dark, those strange little stars just keep ticking. Like cosmic heartbeats we're still learning to understand. Tick, tick, tick. Tick, tick. Out in the constellation Cygnus, about 1,170 light years from Earth, there's a star that looks perfectly normal at first glance. It's called KIC 8462852, but most people know it by a much easier name. Tabby's star, named after the astronomer Tabitha Boyajian, who led the team that brought it into the spotlight. Now, let's pause for a moment. Think of how stars normally behave. They shine, steady, bright, predictable. Sure, they might dim a little if a planet passes in front of them, what we call a transit. That's how we find most exoplanets. When a planet like Jupiter crosses its star, the light dips slightly, maybe by 1%, sometimes less. But Tabby's star, it didn't dim by 1%, it dropped by 15%, and then 22%, and not just once, over and over, but irregularly. Sometimes the light faded for a few days, other times for weeks. No pattern, no rhythm. Imagine flipping through a night sky and one star is blinking wildly, like a broken street lamp. It was one of the strangest things ever seen by the Kepler Space Telescope. So naturally, astronomers asked, what could be causing it? And here's where it gets wild. First theory, dust. The most basic explanation, dust. Maybe a swarm of comets or debris from a shattered asteroid was orbiting the star, occasionally blocking its light. It sounds simple enough, but the amount of dust needed to dim the star by 20% would have to be enormous. Worse, the light dimming wasn't the same across all wavelengths. Normally, dust scatters blue light more than red, which would give the star a reddish tint, but that's not quite what we saw. So, the dust theory started to feel a little shaky. Second theory, a giant ring system. Another idea. Maybe there's a planet with massive rings, think Saturn, but 100 times bigger. This planet might be tilted or wobbling, causing its rings to block the star's light in complex changing patterns. It's an elegant theory, but no planet has ever been confirmed orbiting Tabby's star. No regular pattern of dips, no solid detection, still just guesses. Third theory, swarm of asteroids or moons. Could it be a cloud of shattered moons, or an uneven belt of space rubble circling the star? Some astronomers thought a planetary collision could scatter debris and create those odd, irregular dimmings. But again, that much debris would create heat and glow in infrared light, and telescopes didn't detect anything unusual. It's like trying to explain smoke without fire. The big one, an alien megastructure. Now hold on, this is not the go-to explanation. In fact, most scientists consider it extremely unlikely. But when Tabby's star first made headlines, one theory caught the public imagination, an alien megastructure. What if an advanced civilization had built something around the star? Something massive. Maybe a Dyson swarm, a vast cloud of solar collectors designed to harness energy directly from the star. Science fiction? Definitely. But here's the logic. The light dips are huge. The dips are not periodic. The structure seems non-uniform. There's no infrared heat glow. If natural explanations fall short, is it at least worth considering? Astronomers even pointed radio telescopes at Tabby's star, hoping for some kind of signal. They heard nothing. But the mystery, still there. What Tabby's star tells us. Maybe it's not aliens. It's probably not aliens. But here's the deeper truth. Tabby's star reminded us that we don't know everything about the sky. It showed us that our models, our confident assumptions about stars, planets, light, dust, still have gaps. It forced astronomers to look closer, to study starlight more carefully, to question what else we might be missing. And in doing so, it opened the door to something bigger, the hunt for the unexplainable. After Tabby's star, scientists began searching for more stars that behaved strangely. They found a few. Some stars dim over centuries, as if something is slowly enveloping them. Others pulse or flicker in patterns we don't understand. A new field of astronomy was born, one that doesn't just look for exoplanets, but for the anomalies, the weird, the unclassifiable. People call it the search for technosignatures. Not just signs of life, but signs of technology. Advanced civilizations, if they exist, might be hard to detect, but they might still leave fingerprints, like odd dimming, unusual heat patterns, or unnatural-looking signals. Tabby's star became a case study in how to spot the unusual. It told scientists, look not just for patterns, but for breaks in the patterns. A star that changed the game. Today, Tabby's star continues to flicker unpredictably. We still don't know exactly why, but we're watching. And because of it, we now pay closer attention to the sky's strange behaviors. It taught us that in the vast calm of the cosmos, there are still places that pulse with mystery, places that refuse to fit the mold, places that whisper, there's more to the universe than you think. And who knows, maybe one day one of those whispers will speak a little louder, and we'll understand. On a warm summer evening in 1977, something very strange happened in Ohio, USA. At Ohio State University, a radio telescope called the Big Ear was quietly listening to the sky. It wasn't searching for stars or galaxies. It was listening for signals. Specifically, signals from space that might just be artificial, not static, not random noise. but a message. Then, on August 15, 1977, at 11:16 p.m., something extraordinary arrived. For exactly 72 seconds, the telescope picked up a powerful, clear signal. Not a beep, not a hum, but a strong burst of radio energy from the direction of the constellation Sagittarius. It was like a shout in a library, loud, sudden, and deeply out of place. The astronomer who noticed. The next day, a man named Jerry Amon, one of the project's volunteers, was going through the printout of the night's data. Back then, the telescope's data came out in long lines of numbers and letters. Most lines were quiet, normal, boring. But then, something jumped out at him, a sequence of numbers and letters so strong and clear, it was unlike anything they'd ever seen. He circled it in red pen and wrote one word in the margin. Wow. And that's how it got its name. The wow signal. What made it so special? Let's break it down. The wow signal was in a very narrow band of frequencies, about 1420 megahertz. That number is special because it's the natural frequency of hydrogen, the most common element in the universe. Scientists had long guessed that if aliens ever tried to send a signal, they'd probably use this frequency because it's a universal marker. And that's exactly where the wow signal showed up. It was stronger than background noise. It rose and fell smoothly, like something moving across the sky. It lasted exactly 72 seconds, the maximum time the big ear could observe any single spot due to Earth's rotation. In every technical way, it looked intentional. So, was it aliens? Let's not jump just yet. Scientists tried to find it again. They pointed telescopes back at the same region. For days, weeks, even years, nothing. The wow signal never returned. And that's part of what makes it so maddening. It was a one-time event. In science, you want things that can be repeated, tested, confirmed. But the wow signal, like a ghost in the wires. Here one moment, gone the next. Could it have been something else? Many people, skeptics, astronomers, and radio engineers have spent decades trying to explain the wow signal. Some theories include a passing comet that emitted natural radio waves, a signal reflected off space debris, a military transmission or satellite, even an earthly source that bounced off the moon. But none of these explanations quite fit. The comet theory gained some attention, especially in the 2010s. But later studies showed that the comet wasn't even in the right place. And if it were a military or Earth-made signal, we'd expect it to happen again. But it never did. Which brings us back to the mystery, why it still matters. The wow signal didn't prove the existence of aliens, but it did prove something else. That it's possible, however briefly, to detect something completely unexpected in the sky. It opened a doorway in the public imagination. What if someone out there was trying to talk to us, and we just caught one word from a much longer sentence? Or maybe it wasn't a message at all, just an echo of some cosmic machine working silently out in the stars. We may never know. But the wow signal changed how we search. It made scientists bolder, more focused, more open to listening. The search for techno-signatures. After the wow signal, the search for extraterrestrial intelligence, or SETI, began to grow. Not just in big radio dishes, but in supercomputers, AI-assisted programs, and global networks of telescopes. Today, SETI isn't just about listening for beeps. We look for laser pulses, unusual chemical fingerprints in atmospheres, infrared heat from large structures, odd patterns in star behavior, like we saw with Tabby's star. These are called techno-signatures, clues that something out there might be using tools, technology, or even energy in artificial ways. And it all leads back to that original idea. If someone out there is trying to be found, would we notice? Would we understand? A signal that echoes. Today, you can find the wow signal in books, podcasts, t-shirts, and science fiction stories. It's more than just data, it's a symbol, A reminder that in the middle of all our scanning, studying, and decoding, we once heard something. Something that made an astronomer write a word in red pen that still echoes through the decades. Wow, maybe it was a fluke, maybe not. But it reminded us of something important: to always listen, always wonder, and always be ready for the impossible. Because the universe is not just full of stars and gas and rocks. It's full of questions, and sometimes it whispers back. Imagine you're floating through space and you see a star, but it looks strange. It's not shining the way stars usually do. Instead, it's glowing faintly, wrapped in something, covered, hidden. Now imagine this. What if that star is being harnessed? Not just looked at, but used as a power source. That's the wild and wonderful idea behind one of the most fascinating alien hunting concepts in science, the Dyson sphere. What is a Dyson sphere? A Dyson sphere isn't a sci-fi weapon or a death trap. It's actually a megastructure, an enormous, mind-blowing piece of engineering. Proposed in 1960 by physicist and mathematician Freeman Dyson, the idea goes like this. Civilizations need energy. As they grow, they use more and more. Eventually, a highly advanced civilization might need more energy than any planet can provide. So, why not capture the energy of a whole star? The Dyson sphere is a theoretical structure that completely or partially surrounds a star, capturing its light and energy. Think of it like building a giant solar panel around your sun, or like wrapping your light bulb in a shell that collects every photon. Dyson swarms, not solid shells. Sometimes, people imagine a Dyson sphere as a giant, solid ball around a star. But in reality, that wouldn't work. Gravity would pull it apart, and the forces involved would be impossible. Instead, scientists imagine Dyson swarms, millions, or even billions, of solar satellites, orbiting the star like a cloud of bees, all collecting energy and transmitting it wirelessly to the home planet, or wherever the civilization lives. These swarms would block some light, not all. So from far away, it might look like the star is dimming strangely, which leads us to a real-life mystery. Tabby's star, a real Dyson sphere candidate. In 2015, astronomers noticed something very weird happening to a star called KIC 8462852, later nicknamed Tabby's star. It would dim by as much as 22%, and then return to normal brightness. No regular pattern, no clear reason. Now, that's strange. Really strange. Most stars don't just dip in brightness randomly, unless something big is blocking the light. At first, scientists thought it might be a cloud of dust or comets, some kind of asteroid field, a rare stellar phenomenon. But then someone asked, what if it's a Dyson sphere? Could it be an alien megastructure? One in progress, not yet finished. The idea made headlines around the world. Now, we don't have any proof that Tabby's star is artificial. In fact, most scientists believe it's probably just dust, maybe complex dust, but still natural. But the Dyson sphere idea reminded everyone that if aliens were building something huge, we might actually see it, not by seeing spaceships, not by seeing aliens, but by watching what they're doing with their stars. Kardashev scale, measuring civilizations. To understand why a civilization would build a Dyson sphere, we need to talk about the Kardashev scale. This is a way to classify alien civilizations based on how much energy they use. Type 1 uses all the energy available on their home planet. We're almost there, maybe 0.7. Type 2 harnesses all the energy of their home star. Type 3 uses energy from multiple stars, even whole galaxies. A Dyson sphere would be the mark of a Type 2 civilization. We're still learning how to use solar panels and build clean energy grids. But a Type 2 civilization? They've moved beyond planets. They've gone stellar. How would we detect a Dyson sphere? Let's say some advanced aliens built one. How would we know? Here's what astronomers look for. 1. Unusual dimming. a star that loses brightness in strange, uneven ways. 2. Infrared excess. A Dyson sphere would absorb starlight and radiate waste heat, possibly showing up as a glow in infrared light. 3. Missing starlight, a star that's too faint for its type. 4. Unusual light curves, patterns that can't be explained by planets, comets, or other natural objects. We now have infrared space telescopes like WISE and JWST that help us scan the skies for these clues. And while we haven't found a confirmed Dyson sphere, we've catalogued hundreds of mysterious candidates worth studying further. What it says about us. You might be wondering, is this just fantasy? It's not. A Dyson sphere is a real scientific concept, but more importantly, it tells us something deep about ourselves. We dream big. We imagine building things not just for comfort, but for wonder. We look at our sun and ask, what if we could capture all of that? And when we look at the stars, we ask, is someone out there doing it already? Dyson spheres remind us that science isn't just about test tubes and math. It's about the wildest possibilities of intelligence, ours or someone else's. One day, maybe us. Could humanity ever build a Dyson swarm? Maybe. First, we'd need to become a Type 1 civilization, mastering planetary energy. Then, build self-replicating solar satellites that could launch into orbit around the sun. Then figure out how to transmit energy safely back to Earth or space habitats. It's not next century stuff, maybe not even next millennium, but it's not impossible. It's engineering on a cosmic scale. And if we can imagine it, so could others. So when we look into deep space, we now ask, is that star just a star? Or is someone building around it? And that question keeps us watching, keeps us listening, keeps us wondering. Because the day we spot a real Dyson swarm will be the day we know we're not alone in building big dreams. You're lying on your back, staring into the night sky. You see thousands of stars above you, maybe a planet or two, and you wonder, where is everyone? We've scanned the skies. We've listened for radio signals. We've sent probes across our solar system and messages into deep space. But so far, we've found nothing. No aliens, no civilizations, no replies, and that mystery has a name, the Fermi paradox. What is the Fermi paradox? The paradox is simple. There are billions of stars in the galaxy. Many of them have planets. Some of those planets are likely habitable. Intelligent life could have evolved millions of years ago. So, we should have seen signs of them by now. But we haven't. So where are they? This was the question asked by physicist Enrico Fermi in the 1950s during a casual lunch conversation. Where is everybody? That question has grown into one of the most important mysteries in science. Space is big. But is it too quiet? Let's look at some numbers. Our Milky Way galaxy has over 200 billion stars. It's about 13 billion years old. Even if only a tiny fraction of stars had intelligent life, there could be millions of civilizations. If just one of them developed space travel and started exploring or colonizing, they could have spread across the galaxy in a few million years, a blink in cosmic time. Yet, we've found nothing. No ships, no structures, no signals. That's the paradox. The galaxy should be teeming with life, but it's silent. Possible explanations. Some hopeful, some dark scientists and philosophers have come up with many possible answers. Let's explore a few. 1. We're early. Maybe. Intelligent life is still rare because the universe is young and we're among the first. We might be in a quiet phase before other civilizations arise. 2. They're too far away. Even if aliens exist, they might be so far that we can't detect them, or their signals haven't reached us yet. Remember, the galaxy is 100,000 light years wide. A message could take thousands of years to arrive, and it might be whispered, not shouted. 3. They don't use radio. They don't. We've been listening for radio signals. But what if advanced civilizations don't use radio anymore? Maybe they communicate in ways we don't understand yet. Quantum signals, neutrinos, gravity waves. We could be listening on the wrong channel. 4. They're hiding. The zoo hypothesis. What if aliens know we're here, but they're watching silently? Just like we observe animals in a protected forest, maybe Earth is in a galactic zoo, protected until we grow up. It sounds far-fetched, but it's a serious idea. Aliens might follow strict rules about non-interference, just like Star Trek's Prime Directive. 5. They're dead. This one is sad. Maybe intelligent life doesn't last long. Civilizations may rise and fall. They might destroy themselves with war, pollution, or AI. Or natural disasters, asteroids, gamma-ray bursts, might wipe them out. This leads us to something chilling. The Great Filter. What if there's a barrier, a great filter, that stops most life from becoming advanced? The Great Filter could be, life itself is rare. Complex life is hard to evolve. Intelligence almost never happens. Or, civilizations always destroy themselves before they can spread. Now here's the scary part. We don't know if the Great Filter is behind us or ahead of us. If it's behind us, then we're rare. We already made it through. But if it's ahead, we may face the same fate as others and not survive. Could we be alone? It's a huge question. Could Earth be the only planet with intelligent life? Could we be the first to rise, or the last left? Some scientists say yes. The silence might mean we are special. Others say we're simply not looking in the right way or long enough. But one thing's certain. If we are alone, then life is far more fragile and precious than we ever imagined. And that makes our job even more important. To protect life, to explore, to survive. The importance of listening. Even though it's quiet, we keep listening. Programs like SETI, Search for Extraterrestrial Intelligence, scan the skies every day using giant radio telescopes. They analyze strange signals, study star systems, and search for the tiniest hint of something unnatural. And every now and then, we get a signal that makes us pause, like the famous WOW signal in 1977. It lasted 72 seconds. It was never repeated. But for a moment, it was hope. We don't know where it came from, and we never heard it again. But it reminded us the galaxy might not be completely silent. Why it matters? You might ask, why should we care? Because this mystery changes how we see ourselves. If we are alone, then we are the universe waking up. We are the first voice in the void. If others are out there, then we are part of a greater story. One that connects stars and minds across the galaxy. Either way, we're living in a chapter that matters. So we keep searching. We keep sending messages. We keep building telescopes and asking hard questions. Because the day we hear another voice, or realize we're the only one, will change everything. Until then, we stand under the stars, we listen, we wait, and we whisper into the dark. Is anyone out there? Maybe, someday, the silence will whisper back. Close your eyes and imagine a bowl of porridge. One is too hot, one is too cold, but one is just right. Now imagine stars and planets instead of porridge. That's where the Goldilocks zone comes in. A place in space where conditions are just right for life. Not too hot, not too cold, but perfectly balanced. Like Earth. Let's explore what makes this just right zone so special, and why it might hold the key to finding alien life. What is the Goldilocks zone? The Goldilocks zone is also called the habitable zone. It's the distance from a star where a planet could have liquid water on its surface. Water is essential for life as we know it. Not gas, not ice, but liquid. If a planet is too close to its star, too hot, water boils away. Too far from its star, too cold, water freezes solid. Just the right distance, water stays liquid. Life can thrive. So the Goldilocks zone is like a cozy ring around each star. A special space where life has a chance. Earth, the perfect example. Our planet sits smack in the middle of the sun's Goldilocks zone. Sunlight warms Earth just enough. Water flows in rivers, lakes, and oceans. The atmosphere keeps things balanced. Life evolved, adapted, and flourished. If Earth were just a little closer to the sun, we'd be like Venus, boiling hot and deadly. If we were just a little farther away, we'd be like Mars, frozen and dry. Earth isn't just lucky, it's in the sweet spot. Every star has a different zone. The size of the Goldilocks zone depends on the star's type. Big, hot stars like blue giants have wide zones, but those stars don't live long enough for life to evolve. Small, cool stars like red dwarfs have tiny zones, very close to the star, which makes planets face strange problems like tidal locking. We'll talk about that soon. That's why astronomers look for medium stars, like our sun, not too big, not too small, just like the porridge. And when they find planets in the right zone, they get excited. Exoplanets in the Goldilocks zone. Thanks to telescopes like Kepler, TESS, and soon, JWST, scientists have discovered thousands of exoplanets, planets outside our solar system. Some of them orbit stars in the Goldilocks zone. For example, Kepler 186f, a planet similar in size to Earth, in the habitable zone of a red dwarf. TRAPPIST-1 system, a family of 7 Earth-sized planets, with 3 in the habitable zone. Proxima b, a rocky planet just 4.2 light-years away, the closest known, and in the habitable zone. These worlds give us hope. We don't know if they have life, but they might have oceans, rain, clouds, maybe even fish swimming under alien skies. But there's a catch. Being in the Goldilocks zone doesn't guarantee life. A planet needs more than just the right temperature. Here's what else matters. 1. Atmosphere. It must have air to trap heat, block radiation, and carry gases like oxygen or carbon dioxide. 2. Magnetic field. It must be protected from its star's harsh winds. Otherwise, its atmosphere could be stripped away, like what happened to Mars. 3. Water. It must have actual water, not just the possibility. Some planets are in the right zone, but are dry as a bone. 4. Stable orbit. If a planet's orbit is wild, swinging in and out of the zone, life may not have a chance to form. So scientists are cautious. They call these planets potentially habitable, not guaranteed homes. But that potential keeps us searching. Why is the Goldilocks zone important? Because it helps us narrow the search. The universe is mind-bogglingly big. Billions of stars, trillions of planets. We can't study them all. So we start with the ones in the habitable zone. Think of it like a giant game of hide and seek. We want to look where life is most likely to be hiding. And when we find a rocky planet with water in the habitable zone, we listen. We look for chemicals like oxygen, methane, ozone, signs that something might be breathing. Could Earth be too perfect? Some scientists wonder, is Earth a rare jewel, perfectly balanced? Or are there many Earths out there, just waiting to be found? It's possible our planet has just the right size, moon to stabilize its tilt, magnetic field, plate tectonics, liquid water, right star. It could be incredibly rare, or it could be one of millions. We just don't know. But every year, we get closer to an answer, the bigger picture. The Goldilocks zone is a powerful idea. It reminds us that life needs balance, conditions matter. A few degrees can make all the difference. And it tells us something beautiful. In a universe full of extremes, fire and ice, gas and stone, there are places where life can bloom. We may find alien oceans, alien skies, alien forests, even alien cities, but it all starts with a world that's just right, just like Earth. So tonight, if you look up at the stars tonight, remember, each twinkle might have a planet, and some of those planets might be in their star's Goldilocks zone, and one of those might be watching us too, wondering if we exist. So we search, we listen, we dream, because out there in the just right distance, life might be waiting. Now that we've traveled through the Goldilocks zone, where life might gently stir in warm oceans and soft rain, it's time to visit some planets where nature went absolutely wild. Some planets are gentle, some are chaotic, and some are just plain weird. Tonight, we'll go on a tour of the strangest planets ever discovered, the ones that defy logic, ignore the rules, and stretch your imagination like a rubber band. So grab your imaginary helmet, strap in, because this part of our cosmic story is about to get very, very strange. 1. HD 189733b, the planet where it rains, glass sideways. Let's begin with HD 189733b, a beautiful blue world. You might think it looks like Earth, but don't be fooled. This is a hot Jupiter, a gas giant that orbits extremely close to its star. Its deep blue color? That's not water. That's from silicate particles in the atmosphere, the same stuff that makes glass. And the weather? 2000 deg Schelm surface temperature, winds that blow over 5000 MAF, molten glass condensing into raindrops. That rain gets blasted sideways by hurricane-speed winds. Yes, this is a planet where it rains glass. Sideways. Beautiful. Deadly. Unforgettable. 2. 55 Cancri A, the Diamond Planet. Next, let's visit a world where you might want to bring a pickaxe, or maybe a diamond ring the size of a car. Welcome to 55 Cancri A. This is a super-Earth twice the size of our planet, and it's incredibly close to its star. Its surface temperature is over 4000 degrees. But here's the twist. Scientists believe that under all that heat and pressure, this planet's interior might be made of pure diamond. Yes, diamond. Imagine mountains made of gleaming crystals. A whole planet forged from carbon and fire. It's not exactly a place to vacation, but it could be the universe's most expensive rock. 3. WASP-12b, the planet being eaten alive. Some planets have bad neighbors. WASP-12b is so close to its parent star, it's being pulled apart by gravity. Its star is literally eating it alive. Tidal forces stretch the planet into an egg shape, and the star slowly strips away its outer layers. Astronomers can see the gas spiraling off into space. In a few million years, WASP-12b will be gone. It's a reminder that not all planets live long, peaceful lives. Some are born to be consumed. 4. Kepler-16b, a real-life Tatooine. You've probably seen it in Star Wars, the famous scene where Luke Skywalker stares at two suns setting. That's not just science fiction. Meet Kepler-16b, a planet that orbits two stars, a binary system. This means the sky on Kepler-16b has double sunrises, double shadows, and double sunsets. It's a gas giant, so probably not habitable. But if it had moons, imagine standing on a rocky surface, watching two glowing suns dip below the horizon. A real-life Tatooine, right out of your dreams. 5. GJ504b, the pink planet. Next up, a planet for lovers of strange colors. GJ504b is a pink gas giant, glowing with a soft magenta hue. It's not pink because of paint or flowers. It's pink because it's young and hot, still glowing from the heat of its formation. It's 4 times more massive than Jupiter and orbits far from its star. Scientists say it's one of the youngest exoplanets ever imaged, only about 160 million years old. If Jupiter is a wise old king, GJ504b is a flaming pink toddler. 6. TRIES-2b, the darkest planet ever. You might think space is dark, but TRIES-2b is darker than space itself. This gas giant reflects less than 1% of the light it receives. It's blacker than coal, blacker than black paint, almost pitch dark. Scientists don't fully understand why. It may have an atmosphere that absorbs nearly all incoming light, with no clouds, no reflection, just darkness. Imagine flying toward a planet and you don't see it, even when you're right next to it. It's like a ghost world hiding in plain sight. 7. PSR B1257 plus 12. Planets around a dead star. What happens to planets when their stars die? Usually they get swallowed or destroyed, but around PSR B1257 plus 12, a pulsar star, scientists found 3 rocky planets. A pulsar is the spinning corpse of a once massive star, blasting out beams of radiation like a lighthouse. These planets shouldn't exist, and yet they do. Somehow they survived or reformed after the star's explosion. A whole system orbiting the ashes of a supernova. 8. WASP-76b, the Iron Rain planet. Yes, we've had glass rain, but would you like some iron rain? Welcome to WASP-76b, a place where one side is always facing the star, day side. The other side is in eternal darkness, night side. On the hot day side, iron vaporizes into gas. On the cold night side, that vapor condenses and falls as iron rain. Yes, molten metal rains from the sky. You'd melt just by arriving. So, why are planets so weird? The universe doesn't care about our expectations. It's wild, free, and experimental. Planets form in many ways, from gas clouds, from leftover debris, from collisions and chaos. And because space is so big, with trillions of possibilities, we find worlds we never imagined. Some hot, some cold, some pink, some invisible. It's like nature is trying out every possible version of a planet just to see what works. Could there be weirder planets? Absolutely. We've only just begun exploring. Future telescopes like James Webb Space Telescope, Nancy Grace Roman Space Telescope, Extremely Large Telescope, will let us peer deeper into space and spot even stranger worlds. Maybe a planet covered in oceans of lava, a planet made entirely of ice, but with fire inside, a planet with floating continents, a planet that orbits a black hole. The possibilities are endless. What these worlds teach us. These strange planets aren't just curiosities. They teach us what's possible. They help us understand how planets form, what atmospheres can be like, how stars affect their children, and maybe where life might exist. Even in the weirdest places, life could find a way, so we keep looking. Because every strange world is a reminder. The universe is far more imaginative than we are, and the truth is often stranger and more beautiful than fiction. Let's take a slow breath. Now that we've toured the wildest and weirdest worlds the universe has to offer, planets that rain glass, burn diamonds, or orbit dead stars, let's return to a gentler question. A deeper question. What makes a planet truly habitable? You've probably heard the term before, the Goldilocks zone. Not too hot, not too cold. A place just right for liquid water to exist. But is that really enough? Tonight, as you lie back and let your mind drift among the stars, let's explore the deeper ingredients that might make a planet not just livable, but welcoming. A true second Earth, a place to someday call home. 1. The classic idea, the Goldilocks zone. Let's start with the basics. The Goldilocks zone, also called the habitable zone, is the sweet spot around a star where the temperature is just right for liquid water to exist on a planet's surface. Not frozen like Pluto, not boiling like Venus, just right. Earth is in this perfect zone around the sun. That's one reason we're here. So when scientists find planets in other star systems, exoplanets, this is usually the first thing they check. Is it in the habitable zone? If yes, they get excited, because water is essential for life as we know it. But here's the catch. 2. It's not just about distance. Other ingredients matter. You can't just drop a rock in the Goldilocks zone and expect it to grow forests. A truly habitable planet needs many other things. Let's explore them gently, one by one. 3. An atmosphere, the blanket of life. Earth has an atmosphere, a mix of nitrogen, oxygen, carbon dioxide, and water vapor. It does many amazing things. Traps just enough heat to keep us warm. blocks harmful space radiation, spreads air and clouds for weather, provides the oxygen we breathe. Without it, Earth would be a cold, airless rock. So even if a planet is in the perfect spot, it also needs a protective blanket. Too thick, like Venus, it becomes a furnace. Too thin, like Mars, heat and air escape. You want an atmosphere that's balanced. 4. Magnetic fields, invisible shields. Earth has an invisible force field around it, a magnetic field created by its spinning, molten iron core. This field shields us from solar winds, prevents our atmosphere from being stripped away, helps protect life from deadly cosmic rays. Mars, sadly, doesn't have this anymore. Its core cooled, the magnetic field faded, and much of its atmosphere was blown away. So for long-term life, a magnetic field is a silent hero. 5. Liquid water, not just a puddle, but a cycle. Water isn't just about oceans and lakes. On Earth, we have the water cycle. Rain falls, rivers flow, oceans store, clouds rise, rain falls again. This dynamic cycle helps regulate climate, feed life, and shape the land. A habitable planet likely needs a stable water cycle, not just a random pond. Water isn't just for drinking, it's for life's engine to turn. 6. Plate tectonics, moving continents, breathing planet. It might sound weird, but Earth's moving crust plays a huge role in life. Plate tectonics recycles carbon through volcanoes, regulates greenhouse gases, shapes continents and oceans, creates rich mineral environments. This keeps Earth's climate stable over millions of years. No tectonics? Carbon might build up and cook the planet, or leak away and freeze it. So a living planet might need a moving crust, not a frozen surface. 7. A stable climate. Seasons, not chaos. Imagine a planet that flips between fire and ice every few months. Not very friendly, right? A habitable planet needs a stable tilt, like Earth's 23.5 degree. A gentle orbit that doesn't wobble too wildly. A balance between heating and cooling. This creates predictable seasons, rain cycles, and long periods of calm for life to evolve. Too much chaos? Life struggles to adapt. 8. A helpful moon, Earth's quiet companion. Earth's moon does more than light up the night. It stabilizes Earth's tilt, slows down our rotation, pulls the oceans into gentle tides. Without it, Earth might tilt wildly or spin too fast, and the oceans would be much less interesting. So some scientists believe that a large, stable moon might help a planet stay habitable. 9. A calm star, not too angry. Stars vary a lot. Some flare up often, blast radiation, change brightness suddenly. Earth's sun is quiet and steady, which is lucky. For a planet to support life, its star should be old enough to have settled down, small enough not to burn out fast, stable enough to avoid frying everything. If your star is a tantrum-throwing toddler, life doesn't stand a chance. 10. The mystery ingredient. Time. Life takes time, billions of years. So a habitable planet isn't just one that can support life. It's one that can do it for long enough. It must be safe, stable, protected, for ages. Only then can bacteria grow, evolve, build ecosystems, and maybe civilizations. 11. What about life that's not like us? So far, we've talked about life as we know it, Earth-style life. But could life exist in methane lakes, under ice, in acid clouds, with silicon instead of carbon? Maybe. Some scientists believe life could arise in extreme conditions, even on planets that look deadly to us. That's why we're also looking at moons like Europa and Enceladus, ocean worlds under ice. Venus's atmosphere, acidic, but maybe hiding surprises. Titan, methane rivers and strange chemistry. So the idea of habitability might be much bigger than we thought. 12. Earth is rare, but maybe not alone. Earth checks all the boxes: Goldilocks zone, atmosphere, water cycle, magnetic field, plate tectonics, large moon, calm star, billions of years. It's like we hit the cosmic jackpot, but out of the trillions of planets out there. How many might have the same luck? Even if only 1 in a million is like Earth, there could still be thousands of truly habitable worlds out there. And with every new telescope, we're getting closer to finding them. So, what makes a planet truly habitable? It's not just temperature. It's not just water. It's a delicate ballet of forces. A dance of distance, air, gravity, protection, chemistry, time, and maybe a little luck. We're not just looking for Earth 2.0. We're listening for places that whisper back, that say, here, life might thrive too. And one day, we may hear an answer, not just in data, but in a signal, a structure, a glimmer, a hello. Let's take a slow breath in and let it out. You're floating in the quiet dark, the stars blinking softly around you. In the distance, you see glowing planets, shimmering clouds, spinning galaxies. But somewhere, out there, is life watching us back. We've talked about habitable zones, strange planets, and what makes a world just right. Now it's time to ask the biggest question of all. How will we actually know if there's life? Not just hopes or theories, but real, undeniable signs. This section is a soft journey into the detective work of the universe, not through giant rocket ships or space battles, but through whispers, through signs, through listening. 1. Looking for alien smells. The science of biosignatures. When scientists want to know if a planet has life, they often ask, what's in the air? Just like Earth smells like trees, cows, cities, oceans, and flowers, planets have scents too. Of course, we can't actually smell them, but our telescopes can read the light passing through a planet's atmosphere. By breaking that light into its ingredients, like a rainbow, we can see oxygen, methane, water vapor, carbon dioxide, ozone. Some of these gases, especially oxygen and methane together, could be biosignatures, signs that something is breathing, eating, living. On Earth, those gases wouldn't stay around without life constantly producing them. So when we find a planet with that mix, we lean in closer. 2. The Great Watchers, our most powerful telescopes. To find these tiny clues, we need incredible tools. Right now, our best space telescope is the James Webb Space Telescope, JWST. It can look at the atmospheres of planets dozens of light years away, detect heat, light, and chemical fingerprints, peek into baby star systems to watch planets form, and it's already changing what we thought was possible. Even more powerful telescopes are being planned. LUVOIR, Large UV Optical IR Surveyor. HABEX, Habitable Exoplanet Observatory. Giant ground-based scopes like the Extremely Large Telescope. Yes, that's its real name. With these tools, we're not just guessing anymore, we're investigating. 3. Comparing planets to Earth, the pale blue dot method. In 1990, the Voyager 1 spacecraft looked back at Earth from 3.7 billion miles away. All it saw was a tiny speck, a pale blue dot. That image taught us something deep. Even Earth, full of life, looks quiet and small from far away. So scientists ask, what would Earth look like from another star? If we find a planet that also looks like a pale blue dot, with ocean glints, cloud swirls, green patches, seasonal changes, a breathable atmosphere, then maybe, just maybe, it's alive too. 4. Listening for signals, the search for intelligent life, SETI. Some scientists take a different path. Instead of looking for bacteria or forests, they listen for aliens. The SETI, Search for Extraterrestrial Intelligence program, uses giant radio dishes to scan the sky, search for repeating patterns, detect signals that don't come from stars or planets. They're listening for something that doesn't sound natural, something like a mathematical pulse, a repeating tone, a beacon, a hello. from the dark. So far, we haven't heard anything confirmed, but the sky is vast, and we've only listened to a tiny slice. Maybe the signal is still on its way. Maybe it passed us when we weren't listening. Or maybe it's still being built. 5. What if we find something artificial? Here's a wild thought. What if we find a structure instead of a creature? Like a Dyson sphere, a giant shell around a star collecting energy, space station the size of a planet, light patterns that flash in binary, strange objects orbiting in perfect geometry. These could be signs of advanced civilizations. Not just life, but intelligence, and maybe technology beyond our wildest dreams. To find something like this, we'd need to spot impossible things, like a star that keeps dimming in weird patterns, or a galaxy with a hole in its energy, or heat signatures that look artificial. 6. Sending our own probes, touching alien worlds. We've already sent probes to Mars, Venus, Jupiter's moons, and even outside our solar system. The next step, send tiny explorers to Europa to drill through the ice and taste the ocean, Enceladus to fly through its water plumes and sniff for molecules, Titan to sail through its methane lakes, or even return samples from Mars. These robotic missions will help us ask, is there DNA? Are there microbes? Is life crawling beneath the surface? Sometimes the answers aren't in the stars, they're just next door. 7. Would we recognize alien life? This is the trickiest part. Even if we see it, would we know it's alive? Life out there might be made of different chemistry, too small to detect, moving too slowly or too fast, existing as a cloud or a network or crystals or patterns of energy. It might not have cells or blood or anything we'd expect. So scientists try to define life in broad terms, a self-sustaining chemical system capable of evolution. But even that might miss something strange and wonderful, so we have to stay open, to be ready for the unexpected. 8. If we do find life, then what? Let's say one day, a signal comes, a telescope spots a weird atmosphere, a probe sends back a blurry photo of something moving. What happens next? First, scientists would double and triple check. They'd debate, publish papers, argue, test again. And if it holds up, it would be the biggest discovery in human history. Everything would change. Our place in the universe, our understanding of life, our hopes for the future. And maybe, just maybe, we'd find the courage to go there ourselves. Final thought. Maybe they're already watching the sky too. As we lie here tonight, floating through this cosmic bedtime journey, imagine this. On some distant world, orbiting a quiet star, a curious mind looks up at their sky and wonders, are we alone? Maybe their scientists are building telescopes. Maybe their children are asking questions. Maybe they too dream of other worlds. And one day, our lights may cross, not as conquerors, but as fellow stargazers, waving at each other across the deep black sea of space. Now, we've reached the end of our cosmic story. All that remains is to drift gently into a peaceful, star-filled rest. Let's take one last deep breath in and slowly breathe out. You've traveled far tonight. From the dusty ledgers of ancient Babylon, to golden rings of Saturn, to the frozen oceans of Europa, to planets that glow pink in alien skies. You've listened for signals from distant stars. You've stood on mountaintops with telescopes and wandered through strange atmospheres where the wind might carry whispers of life. Now, you're floating once more, weightless and calm. The stars blink around you like lullabies. There's no rush here, no worries, just the slow rhythm of the cosmos. Planets turn, moons rise, galaxies swirl, and you are part of it all. You are not just looking at the universe, you are made of it. Carbon from ancient stars, iron from dead suns, water from comets that kissed the early Earth. The atoms in your bones were once part of something enormous, something old, something beautiful, and now they rest here, wrapped in warmth and starlight. The universe is quiet tonight. It is watching, waiting, and dreaming, just like you. So close your eyes. Let your thoughts drift like satellites. Let the gentle gravity of sleep pull you in. You are safe. You are small. You are infinite. And somewhere out there, the stars are singing you to sleep. Good night, explorer of the unknown.